Now we're going to move on to the transport layer. The transport layer controls communications between end hosts or between end devices, between end hosts. The transport layer controls communication between end devices. This communication between end devices can either be reliable or unreliable. So, Transmission Control Protocol, or TCP, provides for this reliable communication or this reliable service. This reliability is provided by sending data and then expecting an acknowledgement for that sent data. Any data that is not acknowledged is simply resent. So, the protocol data unit at layer 4, this data being sent, is called a segment. What does a segment look like? Well, before we look at the segment, again, at layer 4, we need some kind of an addressing scheme. So some kind of a source address and some kind of a destination address. The addressing scheme used at layer 4 are simply called ports. Ports 1 through 1023 are well-known ports. For example, Telnet, the service Telnet, a way to remotely log into a device, uses TCP port 23. Port 1024 to 49151 are registered ports with IANA. These are ports requested by companies for certain services, and IANA registered them with that company for a certain service. The last type of ports are your ephemeral ports, and these are your open ports. Any protocol or any service may use the port range between 49152 and 65535. Now, when you add ports to a packet, it is called a segment. So the segment is the protocol data unit used at layer 4. You have your destination IP, your source IP, and then I have inserted the destination port number and the source port number, followed by the data field, and again, the frame check sequence field housing the cyclic redundancy check. Now, before this reliable communication can happen, or before the segments are sent between devices, the devices go through or create a virtual connection with each other by going through what is called a three-way handshake. So here we have depicted host 1 and host 2 performing this three-way handshake. Host 1 sends host 2 a segment with the synchronized bit turned on, or a synchronized segment, or a SYN segment. Host 2 replies with an acknowledgement to that sync with a sync ACK, or synchronized acknowledgement. And then host 1 sends back an acknowledgement acknowledging the sync ACK. After this three-way handshake is completed, a virtual connection is built between the two end devices, and now data transfer may begin. So, by default, for every segment that is sent, I expect an acknowledgement in return from the other end. If I do not return, or if I do not get an acknowledgement from the other end, I simply resend this segment. Now, the number of segments that can be sent per data flow without expecting an acknowledgement back is called a window size. By default, or in the very beginning, the window size is 1. So 1 acknowledgement for each segment sent. This window size can increase because that way it's more efficient. I may be able to send 10 segments and just expect 1 acknowledgement back to quicken the data flow. This ends the transport layer lecture.